Okay, so I do want to finish up real quick, at least to talk a little bit about the projects. First off, good job. I actually think this is the first time, well, not the first time, but this probably is the first time where every project at least had something running at the very end. So that's actually pretty impressive, or at least every project that was presented. So maybe there's a fifth project that just didn't happen, but that's okay. So real quickly, what are a couple of things that y'all learned working in a group? Or actually, let me, before I ask that question, how many have y'all ever done a software project as a group before? Okay, besides last semester in this class. So this is the first time you've ever done it. So I'm going to switch the video over, so now we're looking at everyone else. What did y'all learn about working in a group with software?
The way we use GitHub repositories without forking it was a lot different than using the class repository.
Okay.
So I mean, it was good practice to learn how to use a different way of using GitHub.
Okay.
This is the first semester I've ever used GitHub.
You used GitHub, right. Okay. But any other, I guess the question is, what did you learn about group interaction?
Real group work is like harder than like what you do in like high school.
Oh yeah.
You can just like do it all yourself, because then it's like you don't see those people every single day for class, and then everybody has their own different schedules depending on what they need to take. So it's a lot harder to meet up. And then social life, work.
Okay. All right.
Those UML things that we had to do,
Mhm.
the design, the one where we pretty much had to stub out the classes,
Mhm.
those were really useful.
Okay.
When writing the code, because I was writing stuff that was depending on stuff from a different class that hadn't been written yet.
Hadn't been written yet, but then you had an interface to actually go
But I knew
get.
what I was writing and it worked.
Right, you at least knew what you were supposed to write. Okay, that's good. Yeah, that's true. Of course, that was really just communication in the end. Okay. So here's a good question. If you have, let's say, a group of 2 or 3 people versus one good programmer, which of those two do you think is going to get stuff done faster? One good programmer. Why do you think that's the case?
People work better alone.
People work better alone?
You don't have to stop and start and integrate and get everybody on the same page.
Right, so there's this communication cost. Now this is actually a pretty big problem in software engineering. Hopefully you'll learn more about this before you fully graduate, but that is really the hugest hurdle with working in a group, which I hope you've at least experienced right now, so you at least have experience. Because what it comes down to is, most of the time, one programmer can get something done faster than 2, 3, 4, maybe even 5 programmers working together, depending on the problem. And that's just an unfortunate consequence of trying to get everyone on the same page, because if you didn't have your UML correct, and then you try and paste your code together, is it going to work? No, it's not going to happen. So there's this huge communication barrier. There's a lot of work out there trying to get around this problem. One was a little bit with UML. Does help. There's a lot of different things that do help. You'll probably learn at some point Agile Scrum, which can kind of help a little bit, at least somewhat, which will help move everything together. But yeah, in the end of it, unfortunately, one programmer can get a lot done, a lot more done than even a small group. But unfortunately, one programmer can only do so much work by themselves. So you, a lot of times, don't see the fruit of many people working on it until you get to about 10 people, which is kind of sad and scary at the same time. Anything else you learned from this group project?
Well, I mean, if you're working in a group and you get stuck on something, one of the other people in the group might know how to help you out with the programming part of it. Like, they may be more skilled in this section than you are, and you need their help to try to correct it, and vice versa.
Right. So there's no. What's great about that is there's no one-star programmer. I mean, yes, there are programmers that are flat out better than others. That's just the way of life. But when it comes down to it, when you get a group and you build your A team, hopefully you'll get to work on a solid group of people. You're each going to have your own skills. So if you hit a roadblock, please ask other people. They understand. Because also if you if you tell, like, look, I have a roadblock, at least management knows that's coming down the pipe. Because the worst thing that's going to happen, and hope y'all didn't really experience this time, which was, I was impressed, is you'll say, oh yeah, it works, oh yeah, it works, and then comes demo day, and of course, it doesn't work. And that's the worst thing, because then management, out on the limb, trying to demo or demonstrate your product and sell it at the same time, and all of a sudden they didn't know about this issue. But at least if you tell them about this issue, they can talk around it. So that's a good comment as well. You have different skills. Make sure if you're having a hard time with something, pass it on to someone else, and you'll probably pick up a different task. And that's perfectly fine. Don't be afraid. There are too many egos in this field. Way too many egos. So that was great. Any other comments? Matt?
I guess I have a question.
Oh, you have a question? Go ahead.
So do most tech companies have meetings every morning to discuss the problems that they're encountering?
So it depends on what process. If you use the Agile Scrum process, you'll have your stand-up in the morning, which means you're put in groups of 5 to 7 people, if they do it correctly, and when you have to stand up, the manager will come in, and each person has 40 to 50 seconds to say what they did yesterday, what they're going to do today, and what is preventing them from getting their work done. And you do that in 50 seconds. The manager, which is called the Scrum Master at that time, will go in and Scrum Master. I always remove that R. But anyways, he'll go down, write down all your problems, and then he'll try and get back to you and solve at least some of them for you. The nice thing about that is if you hit a roadblock, you find out very quickly. If you're not making progress, it's very obvious that's the case. But on the flip side, you have to go to a meeting. And I don't know, anyone like going to meetings? The look from the Spayware employee was priceless. Yeah, meetings, lots, and also a lot of these things, like your stand-up, can be done in an email and be done more efficiently because then there's a written record. So there's pluses and minuses to it. There's also other models, waterfall and spiral. You'll learn about them in system analysis and design. And the thing about it to keep in mind is no one process is, there's no silver bullet. There's no one thing that's going to solve everything. So you find someone who thinks everything should be done one way. Be wary and be prepared for sadness to occur, because they'll try and solve every problem with one thing. So that was my spiel. Great question. Any others?
No.
No questions? By the way, adding the humor in is always very helpful, especially when you're trying to work with a group of people, because I love the memes. They do help. Of course, don't go overboard, but they do help a lot when you're in the workforce. Obviously,
You don't want something bland.
Yeah, you don't want something bland.
I could have included just pictures. There's no wow factor.
There's no.
Bland about an old-fashioned game of checkers.
Well, no. I'm not saying that. I'm just saying for a I didn't want just pictures of people working out. Regular pictures.
Should have been you work now.
Yeah, it should have been me.
It should have been you.
We'd be good
Before and after.
I like it. What you doing, Nicole?
Sizing pictures
Oh, okay.
for my website.
Any questions or comments about working in a group? Did you enjoy it?
I liked my group.
You liked your group? Yeah.
I like my group members.
My group members. No, maybe not the project.
I'm hurt.
You're hurt?
Yeah.
All right. Any other questions? Did y'all see why Git, or not necessarily Git, but a repository system would be helpful? Hmm? Oh, it's class time. Yeah, any type of repository. There's other repositories besides Git. There's Subversion and plenty of others. But do y'all see why that would be useful, or was it only 100% pain? I'm sure it felt like a pain right now.
Saw both sides of it.
Yeah. You're at least able to see both sides of it. Okay, that's good.
When I knew how to use it, it was awesome.
Yeah. Exactly.
But when I was feeling my way through it, not so much.
Yeah, unfortunately, Git is one of the more complicated ones. The technology is complicated, but it has the best support. So it's kind of a hard, like if I went with Subversion, being able to use it would be a lot easier, but when you had problems, it'd be harder to Google and research what that problem is. So there was a balance there. And I just chose Git just because of the support, and everyone keeps moving to a distributed repository system like Git. You may use Mercurial or Darks or whatever else out there. It's going to work basically the same way, just it's called something different, your commands are different, your tools are different. It's doing the same thing.
The history of files in Git was very nice.
Mhm.
I was able to go back and it shows you what you changed.
Oh yeah.
Through each commit, like it has minus lines, what was taken out, and add lines, what was added.
Even tells you who did what, which is great when you want to start playing the blame game. It's a lot of no, don't play the blame game, but it's nice that you can figure out what happened where, and you can also pick out and revert certain changes once you get good at it and come out with a base code of what you want afterwards, which is pretty nice. And then there's branches, which we haven't gotten to yet, and that's the most powerful feature is you have your main code, and then someone branches to do whatever, and once that's working, they can push it back to the main trunk, and that's its biggest power because you can branch someone create their branch, then someone can branch the branch and keep branching and pushing, moving it all back together, and that's the most powerful feature of Git is it made that whole feature really, really easy to use. We didn't do that here, but out in the workforce is incredibly useful and helpful. Okay. Any other questions? Any other questions about this group project? Y'all seemed a lot, what's the word? More amicable about this. Last time I had some impressive emails saying this person doesn't do anything, they don't deserve to be in your class. Yeah, you need to give them an F. Yeah, I got some interesting emails last time. And most of the time I get some anger, but this time not too much. All right. Okay, cool. Let's go over your midterm. All right, closed book, no notes on neighbors. Basically, this is the midterm. When is it scheduled? April 27th from 0800 to 1000 in this room. It's online, so if you don't show up at that time, that's okay. Just finish it before Friday at midnight, because I will probably finish grading it over the weekend, get your final grades turned in. And then I will not be too available after that. On May 1st, I'm not going to, May 1st moving onwards, I won't really be available, so make sure you get everything in before then. That also goes for getting all your labs in. When does that due? Is that today?
No.
Tomorrow? 27th? Wow, I'm nice. All right.
What about I think I'm late on this, so probably I'll have the ethics paper.
Yeah, I get you ethics paper, Ed.
Due last week. Yeah.
Just get your ethics paper, Ed.
I will, I've got it done, so.
Okay. We'll turn it in.
Today.
All right, what do we have? The test will be answering a bunch of questions about Java, well, really OOP, more than Java, but you will be reading Java code and answering questions about it. There will be a short section where you'll write some Java code. So please try and write it to your best. I'm not going to be 100% nitpicky about it. If you forget a semicolon, I'm not going to take, minus 20 or something. Just make sure it's obvious what you're doing. So some topics. Understand what extends modifier does. Ooh, that was bad. Understand what extends does with the class. Make sure you understand the basics of OOP with extends, inheritance, or implements, I mean. Also be prepared to read a UML figure or diagram that shows inheritance, and I'll probably ask you to stub it out. Here's the diagram. What would the code look like if you were going to write it in Java?
Does it tell you when something's spelled wrong?
No, it doesn't, because that's definitely not spelled correctly. Yeah, that's better. See, interface. Oh yeah, same thing with, that was extends, now with interfaces for inheritance. When do we use an interface or inheritance over composition? Make sure you know the difference between the two. Quickly, what is the difference between inheritance and composition? What's the relationship? Yeah, inheritance is which one?
Inheritance is a.
Right. Composition is as a. There we go. Perfect. Let's see. Regex, be able to recognize basic regex and come up with a simple regex to parse. Okay, you don't have to do the second part. But be able to recognize what a basic regex command is. I'm going to ask you what is this what is it parsing? And hopefully it won't. You'll just need to tell me. Give me as much information as you can about what it's trying to parse. Understand a stack works. We talked a little bit about a stack. That's last in, first out. And that's the data structure. We did a little bit about, what was it, reverse Polish notation and be able to do, let's see, regular expression, or not regular expression, I'm sorry, mathematical expressions, arithmetic expressions, there we go. You know, you have numbers, plus, actually do all those. Recursion, we did talk a little bit about recursion. Understand what infinite recursion is, why do we have a base case, will a certain piece of code ever terminate or not. We talked about lists, sets, and maps, so understand how each of those work and why you'd want to use one over another. We went over solid, so please review solid and each one of those letters about the acronyms, why each one of them is important. Again, UML, I'm going to give you a UML diagram and ask you to stub it out. Hopefully y'all understand how Git works. I'm just going to ask you some basic questions about Git. I'm not going to ask you to actually check out a repository or do anything about it. I want to make sure you actually understand why we use Git and how the general need for it. Do you understand the different types of memory? I hopefully tried to beat this in over the course of the semester. I tried to talk about it. This is with the stack, the heap, and static portions of memory. What part of your code or your program is in each one? Your code's usually in static. Local variables are on the stack, and then usually, or when you do a new command, that's always stored on the heap. That's probably the easiest way to keep it in mind. And oh yeah, what happens when the stack meets the heap? Yeah, what happens when the stack overflow? Memory out of memory. Out of memory is the big one, but stack overflow, sure. All right, it's going to be on Blackboard. Just like your midterm, scheduled for there. You'll have 2 hours to complete it. I wrote it so that it'll be completed within 90 minutes. Or I would expect a student to complete it in 90 minutes. Let's see, anything else?
Is this online? Is this on GitHub?
Yes, it's on GitHub. I have created a team survey after your project. The survey is graded, so you need to fill it out to get that portion of your grade. This has to do with your class project. So make sure you fill it out so I can better evaluate you and others' contributions to the team. This is your moment to tell me what you did, and if you think a team member didn't do as much work as they should have, that is also the time to tell me as well. Of course, I'm going to go in and look at GitHub and see who pushed what. So make sure that if you didn't push everything, you spell that out for me. Let's see. Yeah, make sure you complete it before April 27th so I can get all your grades in. All right. Any questions? All right. On Blackboard, I can't show you right now, there is a final, or I've done all the grading once, and I'll do another grade through after the 27th to update everyone's grade. There is a column that is your final grade that I'm going to report. That's assuming a 0 for everything that I have not turned a grade in. So right now it's pretty low, that's why. But as I put the grades in, you'll see how that's being calculated, and you'll see what you need to do to get whatever grade you need for this course. Any other questions? Nothing else? All right, guys. Well, thank you very much. I always enjoy doing OOP. Yep. Have a good summer. Hopefully I'll see y'all next time. Some of y'all taking data structures?
Yeah.
Yeah. All right.